All right, we're going to look at two rules called product and quotient rule. First, we're going to find the derivatives of each of these. So we're going to use those little pattern methods we learned prior to this on how to find the derivative. And remember, this little prime symbol here means we're finding what's the rate of change. And so our rule is to take that power, drop it down. New power becomes one less, so this would now be 2x to the first power. If it's to the first power, you don't need to write that. Our next one, we're going to do the same thing. So our derivative or rate of change here is drop the exponent down, 3. New power is one less, which would be 2. So this equation, 3x squared, would help us find the slope anywhere. So if you wanted to find what's the slope at 1, plug 1 in, and it would give us that the slope there is going to be 3. So we know the slope on that graph at 1 ends up being 3. All right, well, what we're going to look at next is what happens if you have some new function that's the multiplication of both of these two together. So if we were to take function f times function g, what's that derivative going to be? Well, one way we could find that out is to multiply f and g together and see what that is. And we know what function f is. It's x squared. We know what function g is. It's x cubed. If we multiply those, we get x to the 5th power. So let's see what the derivative is of this. Derivative, one way to write derivative is using that prime notation we did on top. Another way to write derivative is like this, d over dx. That's called the Leibniz notation. So derivative of x to the 5th would end up being, use our power rule again, drop the 5 down, new power is 1 less. So the answer to this one should come out to be 5x to the 4th. Well, what we want to check is that the same as just taking our equation here and just taking the derivative of both. So in essence, is this equal to f prime times g prime? Is that going to be what the derivative of this is? Well, we know what f prime is. It's 2x. We know what g prime is. It's 3x squared. If we multiply those, do we get the answer we should, which is 5x to the 4th? Looks like we don't. And so what this tells us is when you're doing this, the derivative of two functions multiplied together is not simply just the two derivatives themselves. We need a new process to do this. And that process which we are going to use is something called product rule. And so product rule, when we want to find the derivative of two functions multiplied together, so again this means derivative over here, of two functions being multiplied, it is not this. It's not just, oh, well, we'll just find the two derivatives, multiply them together. Not it. We got to use this product rule. And how product rule works is you take one of the functions and multiply it to the derivative of the second one there. Then there's this plus sign, so we got to add, and now we're going to switch around the two things we just did. So you're going to take the other function and times it to the other one's derivative. That's product rule. This is something you'll need to know for the exam. Definitely going to be tested on it. Let's just show you that it does in fact work. So I'm going to go back to the problem where we already know the derivative comes out to be 5x to the 4th here. Let's apply product rule and see if we get the same thing. So product rule, from what we just had, is f of x times g prime of x plus, switch them around now, g times derivative of f. And we found all those things already here. So f of x is our x squared. G prime, we found that's 3x squared. Plus g of x we got, that's x cubed. And f prime of x, that's 2x. And so if we multiply here, we get 3x to the 4th. Plus, multiply these other two, we get 2x to the 4th. Add them up, we get 5x to the 4th. Is that the same answer as here? Absolutely. You can see there that product rule does in fact work to get a derivative. So that's what we need to be using anytime you notice a problem where you got two functions multiplied. Here's an example of one of those. Use the product rule to find this derivative. This one, you can see we have two distinct functions here. One of those functions being x, the other function here being e to the x, and they're both being multiplied together because we see no symbols in between these, so they got to be multiplied. So to start with, it might be good over on the side somewhere to actually find those two derivatives now. So derivative of x, that's like x to the first, so we're dropping the 1 down, new power is 1 less, which is 0, but anything in the 0 power is 1, and so this just ends up being a derivative of 1. Derivative of e to the x, we've talked about that one. That's an easy one. It's the only function whose derivative is the exact same thing, so that derivative is e to the x. So let's write out now what our derivative is going to be here. So our derivative of g is going to be the first function, x, times the other one's derivative. So we want to multiply those two together. Plus, product rule always has a plus. Now we're going to take that second function, e to the x, and multiply by the other one's derivative. So we're multiplying those two. So times 1, but times 1's not really doing anything. So there would be our derivative. So that would be the derivative or rate of change of g. That would be the slope. This equation would find the slope of this function at any point. All right, now follow-up question that they may ask on certain problems. Now they want us to find what's the second derivative of this. Second derivative is a real thing. It's often used in some problems here, and how you indicate it with this notation is to use 2 apostrophes. That indicates second derivative. And what second derivative is it's a rate of change of a rate of change. One example that we will be using coming up is the rate of change of velocity is called acceleration. So an acceleration is an example of a second derivative of your position. So how do we find this? Well, now what you want to do is find what's the rate of change of this thing we just found up here. What's the derivative of a derivative? So to do this, we have kind of 2 parts up here. We're going to have to find the derivative of this stuff I just underlined in red. We also need to find what's the derivative of that thing in blue. The blue one's pretty easy. That's just one term there. Derivative of e to the x is going to be e to the x. So this is the derivative of that stuff in blue up there. The derivative of the stuff in red, there again we have 2 things being multiplied. So we got to use product rule again when finding that derivative. Well, that actually ends up being the exact same problem we just did. You can see e to the x times e to the x is the same thing we started with. So the derivative of that part should just be end up being the exact same thing we just solved for. X e to the x plus e to the x. And so now the last thing we can do there is we could simplify. If you got e to the x plus another e to the x, we could write that as plus 2 e to the x. And that would be our second derivative, the rate of change of the rate of change. All right, why don't you pause the video and try this one out. See if you can find this with product rule. It might help to start off on the side again and write down your 2 functions and find those derivatives to start and then apply it to product rule. All right, let's see how you did here. First off, those derivatives, use a power rule, bring 2 down. You got 6t now. Derivative of a constant, this 6 here, derivative of a constant should be 0. Power rule on the other side, you get that. So now when we're doing this, you want to have your first function times the derivative of the opposite, or the other one. So we want to be multiplying those 2. And then we got our second function here, which is this one, times derivative of the other one. Go through here, you're going to have to kind of use that, FOIL it out to get that. Here, make sure you distribute to both, and if you simplify, you should have gotten what's circled there. Now, this is an example of one, though, that could be done a second way that you wouldn't have to do product rule. So sometimes you can maybe simplify first in order to do this and avoid using some of these rules. The last problem we did, no way to do that. You can't simplify that any more than it is. But this one we could. We could start by foiling this out. So if I FOIL this out, I'm not finding a derivative here. I'm just multiplying what's up there. If we multiply the first stuff, we get this. If I multiply the inside ones, I get this. If I multiply those outside ones, I'm going to get this. And if I multiply those last ones, I get that. That now does not require product rule because each one by itself is just one little function there. So what's the derivative of what I got right there? Bring down the 6, that's 18t to the 5th. Bring down the 4, minus 24t, powers 1 less. Bring down the 3, multiply it to 6, powers 1 less. Bring down the 1, that's negative 12, powers 1 less, which is 0, so this is what you get. You notice, is that what we have down here? Yep. So that's a quicker way of doing it. Sometimes if you can simplify first, you can avoid doing product rule altogether.